So, Nico, the floor is yours.
Good evening from my side. Okay, so I will kindly ask the participants in this industry panel, namely Marios Patichis, Anastasios Doulamis, Betty, and Marios Milis, to switch on their cameras if possible. Okay, thank you. Thank you very much. Thank you very much. So, Tasso, I cannot see you. Okay, Tasso is on board as well. So, let me share the screen of the program just to show you the short CVs of our panelists today. So, this is the industry panel of Caip 2021. The theme of this panel is industry's challenges in meeting emerging markets in image and video analysis. Together with my colleague, Theoto Haridis, we will be moderating this discussion. We have 4 panelists, most of them good friends from the past and still now. So with us will be Betty Haralabopoulou, the CEO and co-founder of Geomatics, Cyprus and Hellas. Anastasios Doulamis, professor of the National Technical University of Athens, very old friend, 20-something years now. Marios Patichis, professor at the University of New Mexico. You can show the short CVs of our panelists here. And eventually we had a transformation. Instead of my friend Anastasios Kounoudis, the CEO of Signal Generics, we have Marios Milis. Marios, what is your status in Signal Generics now? How can I
now I'm head of
refer
software.
to you?
Head of software.
Oh, head of
development.
software. So the panel will be the duration of the panel will be 1 hour and 1.5 hours. All panelists will be given 10 minutes to introduce themselves and the industry, hopefully application they like to show to us, and we will leave 45 minutes for discussion. I do have some, I think, triggering questions for you regarding the theme of this panel. And without any further delay, I will kindly ask Betty to start with her presentation. So I will stop sharing, and Betty, are you ready to share your screen with us and introduce yourself and the activities of your company?
Nicholas, congratulations for the effort for this event, and thank you for the invitation. I'm going to share my screen now. I don't know if you can see the...
We can see your screen. Try to make it full screen, please. Thank you. This is okay now.
Okay, it needs some time. So
we see the notes.
Just
Swap.
just a short introduction, Geomatic Cyprus Ltd was established first in Limassol, and the last 2 years is based in Nicosia. Is working with Earth observation and ICT services. In parallel, in Greece, we do have another company doing similar technological jobs. The name of the company is Geosystems Hellas. So I'm just going to present some ideas that we have been working with the last 5 years, just after the, let's say, push of the technologies of the 4G and 5G for several applications. And I have selected the cultural heritage because it's a subject very much interest for the Cypriot market, which is a market with a great cultural heritage monuments that gives a quite big portion in the economy of the tourism in the island. So what Geomatics is doing is trying to fuse information from the real and the digital world in order to give actionable data in order to be used from the everyday people, and like that serve with actionable information and kind of market. So in this market, as far as you understand, the technologies are mixed. The technology always for Geomatics, as the wording of the company name says, is that our major interest is the location. And the second interest is the change, means that we geolocate any kind of information, even coming from terrestrial cameras, from mobile phone cameras, and so on. And the second interest, which is the change, is the information that with the use of artificial intelligence can give us the data that can be used as intelligent data in order to facilitate our lives. What is interesting in those technologies is that in 10 years ago, it was technologies used only by experts. When I say experts, I mean academic and institutional experts that have been using satellite data, airborne data, or UAV data, or sensors, geodetical sensor data, GPS, etc., in order to achieve their goals. Nowadays, this is quite more different because it came down to the everyday use because this data is available even in our mobile phones. So everybody is very much interested on these technologies. And this will be more massive the next years because of the explosion of the 5G. The 5G is given to us, to the citizens, to the simple citizens, the possibility to gather bigger data in no time and accommodate this big data information with extra tools that each of us would like to use according to projects or interests that all of us can use. As add-on to that, because of the strength of the satellite data, because this is something that nowadays with Elasat in Cyprus is something that is currently a fusion of strength between the terrestrial and the satellite communication. This gives some extra possibilities also by AI, let's say, methods, in order that to cover, even if we do not have enough terrestrial strength, to cover the connectivity. Because connectivity is significantly important. And this we found all out during the period of the lockdown, because now everything is remotely, and used to be more difficult the year before, because this remote push wasn't mature enough and technologically and sociologically from all the people to use. But now it's part of our life. I think by the end of this year, this will give new trends in all markets. So this is the digital society. I do not have more to say on that. This is the digital society, this is the digital economy, and it's an opportunity for every kind of market. It's an opportunity, the 5G network technology is an opportunity that we will see how it will change our life in the very close period. As add-on to that, the use of the value chain of the blockchain and the distributed letter technology as add-on to the machine learning and to autonomous vehicles and drones, we pass in a very good progress on monitoring the cultural heritage sites. And the cultural heritage sites, we have to think for them that these are parts of a smart city, because the cultural heritage sites used to be for the ancient Greeks and in Cyprus, used to be a smart city for them. So like that, we can analyze, we can understand about the population of those days in the past, and also we can somehow connect the tourists that visit those sites with the real historical archaeological information of those sites. It's strange, but as geomatics and not as Greek entity, we have been monitored with airborne data the old city of Corfu, and there was a production of the castle area with density matching. And of course, there was production also of ortho images that in very accurate building information, we managed to get the exact information and also combine it with archaeological databases that the Ministry of Culture has given to us. That was a task in order to construct 2 or 3 buildings and the church that have been suffered because of the material degradation. Of course, any state-of-the-art photogrammetrical and remote sensing methodology have been used. And also, as add-on to that, there was from the same group another effort with airborne LiDAR in the surrounding area of Ageira. Ageira is an area in Peloponnese close to in the Achaia region. And in this area, with similar technologies, airborne sensor with LiDAR and image camera in simultaneously acquisition over the area of interest. You can see on the left side the flight plan as it was designed, and on the right side the flight plan as it was executed. Very much a very big difference, but with this let's say trajectories, we overcovered the area with more of overlaps of 95%. So there was a very dense point cloud and then a very dense imagery coverage. And as a result of that, we got the information of the archaeological site stadium, Theatro, and that you can see in those screenshots. And that was a very, very accurate process that at the end we got information at 2 centimeters with airborne coverage. This means that the whole execution was 40 minutes flight, 40 minutes, not even 1 hour. Like that, we saved a lot of time, and we promoted this to a company that works in the headquarters is in Dubai. This company Mayer get jobs from the United Nations and the World Bank funding over several areas, and we got a project, a small project in Moldavia, which we proceeded with same technology. Okay, in Moldavia, the cultural heritage is totally different than the ancient Greek style that we can see. But even there, the acquisition and results, that was a little Viking situation, sorry for saying that, were quite successful. And because this monitoring gives degradation, and this is something that I would like to push a lot for the sites, cultural heritage sites in Paphos and surrounding areas, is because we have been through with university in UK for a sharp multi-process, let's say, deformation monitoring from the big area, not only the Paphos area, but you can see in the next slide the area that was covered, in which we understood that this is quite interested because there are positive indicators in several areas. You can see the red areas and the orange areas in which, if there are cultural heritage monuments or old buildings, will suffer. And this, because of the climate change, is not movements only from earthquakes or geological inputs, but because of the climate change, this can be soil degradation or degradation that will provoke extra damages in cultural heritage areas in Cyprus. Since this is a must inside European Union, I have selected a theme, which is a group of efforts that ESA is doing for cultural heritage the latest period. It's a theme that is called Artes, and it's dedicated to cultural heritage. That, like that, we do use remote sensing and other tools in order to achieve sufficient information that it's very much connected with the economic life. And in all this, you can see how much interest is the satellite communication, the UAV operations. We serve like that with space technologies and with AR, VR, and UAV method use. We serve the cultural heritage, and this is a new trend that will be around the European fundings the next period. That's the remote sensing services forecasts up to 2025 means that there is a market in front of us, and because it's a lot of dollars, it's billions of dollars, these are technologies that should be better be evaluated, and also we can somehow have a growth around these technologies and in Cyprus and in Europe. Thank you for your attention. Happy to answer any questions during the roundtable.
Thank you, Betty. We are moving to Anastasios Doulamis. Tasso, you can continue. We'll have, as I said before, the discussion at the end. Try to keep the 10 minutes though, because I think that we are moving away of the schedule. So try to keep the 10 minutes.
I will keep. Thank you, Nikos. How can I share my screen? Just a moment. Do you see my screen?
Right, we see.
So it's good, we can see.
Okay, so I will keep the 10 minutes, okay? My presentation is dealing with computer vision techniques in critical engineering infrastructures. My name is Anastasios Doulamis, and I'm an associate professor at the National Technical University of Athens in the field of computer vision. I'm going to send you some experience that we have in involving in some industrial projects in European Union with big companies, very big companies, giving with the impact of computer vision in industrial applications. First of all, one slide, just what is a computer vision? Is the ability of any computerized system to see. So as the humans, we have some sensors on our body, the eyes, and we can see through them. Not only we can see, but with the verb see, we think that we can interpret, we can analyze. So this is what we wanted to do for the computers, any computer system, from mobile phone, from laptops, from desktop, from any system, from big or small, even pervasive computerized system, is ability for visual, for images, or for digital images or videos, for visual content, either in the visible or in the broad visible field, meaning beyond the visible spectrum, hyperspectral or multispectral image content to be able to see. Now, few things for what ability. We have in the early of 2010, we have of this decade, we have involved in a big project named SCOVIS with Nissan automobile industry in Barcelona. The goal was to put cameras in the manufacturing construction company in order to see how the assembly is going on, and through the computer vision to assure the quality of the assembly and to prevent the safety and the security of the workers. This is some examples of these data sets that we have. It's actually, we have installed 4 cameras inside the company and 1 panoramic camera, and we can monitor, track, and make any surveillance of the people. It's very tough data set, which almost all of the computer vision algorithms have failed, because we can see that even the roof is moving through the robotics and the wires, and there are several fires, and you can see that prevent just a moment to open the laser pointer. Here you can see that there is many fires that prevent the visual content. Now, what we can see here is that we can make some algorithm to track the behavior and the normal paths, through maybe through unsupervised learning, which try to find out some situations and conditions. It's this very difficult data set. Now, another work that we have done is inspection of tunnels in road infrastructure. This was done through the RoboSpect project that we are in the coordinator team. This is the robotic part that was constructed from one company in Spain. It was weighted 7 tons. And this was a huge arm on this robot. The idea is that we have, of course, put cameras and laser scanners and any other devices on the road. The robotic was implemented in Egnatia Road in Macedonia, in Greece, which is a big avenue. The toughest situation here is that during the final review, the reviewers and the European Union told us that we don't want to make any review for slides, but we wanted to go to Egnatia to show the system works. So the review was only 1 or 2 hours, so we close one lane of the Egnatia to show the system work, which of course is very difficult, a tough situation, because it's affected by the outdoor conditions. And this is some results for the vision camera, some results for the cracks, because the idea was to locate the cracks, and the cracks was a depth only of 1 or 2 millimeters. So the crane should, through the computer vision system, should guide the cracks in order to localize them. We have made, of course, some papers, article here, which have received many citations. This is another system from Inarchus research project, which is detecting victims using thermal cameras in collapsed buildings, like, for instance, what is on the left for a building in Italy, the famous L'Aquila earthquake. So we have also these thermal cameras or snake robots, and the idea was to identify and to detect the victims in order to use, of course, photogrammetric tools and real-time 3D reconstruction in real time, not real time, but not in one day, because the time is crucial. Then one project that is going to end, and the leader is the coordinator is Airbus, that we also involve is to detect effects in road infrastructures like cracks or other problems, breach, rust. So we have make it through UAVs or other cameras. It's very interesting approach that we can perform. This is some results that we have just sent for publication to the Automation Construction Journal. Actually, this Sunday was the deadline for the revised manuscript to be received, and today we are personally working on this. It's almost final. So the content is to classify the rugs using some machine learning techniques, residual attention unit networks, etc. So you can see what is the impact of machine learning, computer vision in detected and expected the ideas. Now another and final contribution, which is crane monitoring in harbors. We have used cameras in order to detect very tough situation, which is the crane in the harbor who's moving along different conditions in real time. This performed in real time and in outdoor conditions. And we have also implemented some algorithms in order to detect the depth and the cameras interior and exterior orientations. through this for the video sequences. The results for the latter cases are not so good, but these are the results for the tracking. And of course, this can be implemented in cultural inheritance, as Betty says, in results in monitoring the material decades. We have done some work, but not have the time to present this, or also in medical applications, which can perform some works dealing with detection of the climate change in urban health environment, and how the people, the citizens, can improve their lives through the vision and the effect of the climate change. So this is my short presentation. Nikos, I think so that I have kept the time. Thank you.
Thank you, Tassos. Thank you very much for keeping up with the time as well. We move to Marios. Marios, please introduce yourself as well, because in the program it is stated Tassos Kounoudis, so I'd like to spend a few words to introduce yourself. We will be happy.
Yes, hello, I'm Marios Milis. I am head of software development at Signal Genetics. I work from Signal Genetics since 2005, since its beginning. And okay, so let's start with can you see my screen?
Yes.
Very well, very well. Yeah.
Okay, great. So in this presentation, I'm going to talk about a product of Signal Genetics, which is a real industrial application of embedded image processing and also artificial intelligence. First, a short introduction about Signal Genetics. It has been established since 2004. We are based in Limassol, and we provide technology in more than 20 countries. We are mainly an R&D company, and we have a strong portfolio of IPR and international patents. We have participated in a lot of European and national projects. We have successfully completed more than 20 projects, and also we are certified with ISO 9001 and 27001, and also we have the secret EU and EU secret certification. Mainly, Signal Genetics has four main operations: research and development, through which we are developing our technologies; electronic product development, where we embed our state-of-the-art technologies in electronics, and then rapid prototyping through our 3D printing facilities. We develop a complete prototypes of the products that we are developing. And the last, smart system integration, through which we are cooperating with other big vendors or other partners to provide integrated system, big integrated systems. Some our facilities, okay, our services, some of examples of our work, both in hardware development, system integration, and also software development. So regarding embedding intelligence in electronic devices, so it's the last years we have a lot of growing demand for smart electronic devices that can process a huge amount of data and that need to be performed in real time, and also to embed artificial intelligence. So this needs more power, and also needs more to be more efficient, to be operated in embedded devices. A smart embedded system needs to have the ability to gather process data, adapt to changes, take decisions, learn from experience, also communicate with other systems, and the more important, to be optimized in terms of battery computational power. So what we do to face these challenges, we give great emphasis in flexibility. We use separate dedicated blocks around an entire circuit and reprogram it to fit the requirements of a particular data processing algorithm. Parallelly, we design our processes in such a way so as to be executed in parallel. So we use FPGAs that can handle multiple workloads while keeping high level performance. Energy efficiency, we design our hardware to maximize energy efficiency by selecting appropriate components and utilizing FPGAs for machine learning. And also packaging. So we design and produce product packaging that enable the implementation of sensor setups and can handle all environmental conditions. So an example of a product where embedded computational intelligence is applied. We have developed recently an automatic water metering device and the whole platform. The metering device is based on image processing. It takes a snapshot of a photo of the water meter. It performs onboard image processing, provides the digit recognition of the meter, and send this data along with some other health conditions of the device to the cloud for further analysis and analytics. And all the results are reported to the end users, either utility, water utilities, or consumers, through also a web application or even a smartphone application. So in order to face all challenges, but for the real application, the most important is to be able to face environmental conditions and also limited resources. So except from image recognition technology that needs to be robust and be able to recognize meter during all times, day and night. So we need to make appropriate packaging and also include some LEDs in the package, so to isolate the reading and isolate all the process from the surrounding environment. Also some other features, scheduled on-air demand reading, secure data transfer to the cloud, extreme power autonomy, more than 10 years. We top up batteries using solar cell. It's run on AA battery source for the consumer to be able to change them. Of course, IP67 enclosure to be protected against weather. Easy installation for retrofitting, low cost acquisition, and the most important, maintenance free. So I have a video to share just to have an idea of the product. I hope I need to. Can you hear the sound? I think so. I need
No
to press
sound for
something.
me. I don't know for the other.
Just share something. I think now it will be okay. Can you hear now?
Yeah, good.
So you can see the whole package.
But we cannot hear you, Marius, now. We can hear the video, not you.
I don't know. I will explain later.
Maybe a bit lower to hear you as well.
Okay, now you can hear me? You can hear me now?
I think it's better, yes. Maybe a little bit
Okay.
lower the
Okay,
sound.
sorry for this. So
Yeah.
we can see the package where we try to isolate the system from the surrounding environment. We can see the camera takes the image. Here you can see all the process for designing the hardware and the assembly of hardware, the new hardware to have the embedded system. This is the fabrication, assembly, and the last the final assembled system will attach the camera. The whole process needs to be robust. It can be assembled very quick and easy. All the designs. It has 4 AA batteries that also the consumer can change. It can be installed very easy. Several designs of the bottom part has been performed in order to fit all meters, the majority of meters. Okay, and also we have developed an application for registering, for configuring this device, and for transferring all for configuration in order to transfer all data to the cloud. Okay, that's all. Thank you very much. I am open to questions.
Thank you, Marios. Thank you. Thanks a lot. What I like for Signal Genetics is that you are real engineers. You fix everything in detail to deliver real products, not only algorithms. So I like it very much to see once again that this is true. So Marios, it's your turn.
Okay. Thank you for inviting me. I think, okay, here's a PowerPoint. So you can see it, right? And now let me go to present mode. Oh. You have to love it. Okay. You guys can see it?
Yeah, okay.
Okay, I'm going to take a little bit of a different approach. I just want to say here from University of New Mexico in the United States, I think one thing to share about UNM, if you are using MATLAB, it's important to, I guess, you're using something that was actually developed here at UNM for teaching computer science students a long time ago. And then, of course, the discrete cosine transform was a PhD dissertation here at UNM. So when I joined UNM, I knew that there was a tradition of developing image processing systems. Here, what I want to do is basically focus on some lessons that I learned. And the hope here is really not to advertise technologies here at UNM, but mostly to give advice on what I learned and from working on this. So one of the products that came out of our lab was the iStar product that is currently being tested in multiple countries, in Africa, in Mexico, and of course several clinics in the United States. It was a startup founded by a former PhD student. Ended up funding another 6 PhD student dissertations, and it all started with a single patent, right? A single patent application. At this point, they're looking at, it got about $20 million from NIH so far. I think that number is about 30 million now. It's been tested on 38,000 patients for a large number of diseases like diabetic retinopathy, macular degeneration, glaucoma, retinopathy of premature cerebral malaria. It's all based on basically work on my PhD dissertation extended here by my students on multi-scale MFM decompositions. I just want to say a more recent story. This is the one I used in my tutorial. We started working with Gassinger, a single student here, and I think I showed you this earlier. This was published in Nature Biomedical Engineering. This, as far as we know, is the largest study of its kind. We started working with Gassinger. They have 3 million patients. My student processed about 1 million videos in his PhD dissertation. He developed essentially a low parameter 3D CNN and showed very convincingly that it destroyed it is so much better than everything else. It was a very simple system. I mean, I presented in my tutorial what the basic idea was. Used an NVIDIA DGX2. Every experiment would take 1 or 2 weeks to run on 1 million videos. And it's a computer-assisted system. It's open source, which is interesting because there's a lot of reluctance there. And then it's going for FDA approval as we speak. Now, what I want to share here is that the biggest lesson learned from a professor and the students, because I guess the conference is mostly attended by the students, is that I needed to understand what it means to have intellectual property protection, okay? And a lot of people in Cyprus have wonderful startups. Andreas Panagiidis has one that, working with the electronic health records, we hope to expand to whole Europe. And that one also started from a patent that we just recently got with Andreas. And it's important to understand that intellectual property by the universities is over transferred to startups that are funded by the students, either personal funds and then usually national science foundations, NIH. The majority fail. I have top students working for free for months. I don't share their stories. I gave you 2, but we have other successful stories like drone technology for the Air Force and things like that. The biggest thing is that we keep contacting the large companies, and they are very reluctant to pay and acknowledge that a university basically developed something that they're using. What they are doing instead is they seem to hire my PhD students, right? So I got like 4 or 5 of them in Apple. I have one in Google. I have, Netflix now, and they go to these companies and they're basically working. They benefited from all the work done in the PhD, all the patents. They seem to be, I'm not going to say violating the patent, but yeah, they're much more likely to get hired. The big thing is that, for the startups, you don't care really much about protecting your intellectual property unless there is big money, right? So I just want to so when do you want to protect yourself? When you have a key invention that can have a very strong commercial impact. And by strong, I mean, it can change the whole industry. The one that I presented at the beginning with AMFM, yeah, I got about $20 million of funding here, but I wouldn't call that, it's not universal, right? So we have amazing convolutional patterns that show how to do it in about 8 N. That's N by N, done in about 8 N closed cycles in the fastest. That is absolutely revolutionary, right? I mean, the FFT that people are using is N square log N clock cycles usually, and we have something that's in 8 N. We're trying to now marketing to the big companies. You would think everybody would jump on it. We're not getting much because they don't want to acknowledge us. But we got some calls, but we didn't get, what this should be done by Intel, not done at the university. But so here's the important thing: if you don't have a prior patent filing, now these patents got accepted. All the convolutions, I have about 10 of them. It's important to understand that everybody who have a published paper, it's open, you can steal it and they can run with it. And if you don't have non-disclosure or confidentiality agreements, then forget it, right? If it's all gone. We learned that lesson early. So software you can protect with copyright, okay? So, and it's very important. It protects over the life of the authors, plus 70 years beyond that. That's like 100 years on the copyright, right? This is why you see companies like Microsoft are doing so well. They even open source it, but they have copyright on their products, and most of the software is done protected through copyright, okay? In the United States, you can file it, and probably less than $100, you can get your copyright registered, and after that, you can go after all the people copying and using your software for copyright infringement. Trademark protection, unless if you have a big name, and people are stealing like Apple, your trademarks, it's a good way to protect you, but unless we are talking about big companies, probably not a big deal. The other thing is to share is trade secrets, and this is very important. Um, okay. If you're once you publish, Nico, there will be no patents. You have to give them to publish, and yes, the inventor who wrote
What I actually mean is that, okay, if you go, if you select the academic route, then probably what you need is to give ideas and hoping that someone else maybe can be turn them into a product. So personally, I wouldn't, have any problem to see a publication of mine to be patented. That's
once it gets published, it cannot patent. That's a key. It come in the next
okay.
slide. Anyway, the biggest thing is trade secrets, and I want to emphasize that. So the famous example is the formula for Coca-Cola. You have very specific information that is specific to your product, like how did you get it running, right? You combine ABC, and some of the parameters, the number of filters, how those are key secrets that you keep them secret. If they go out, you're dead, right? I mean, you lost. There's no trade secret. So if you're doing a patent, if you decide to do a patent, there's a lot of advantages for the patent. Is that they protect. Nothing protects the idea, but it protects the invention. Then you have to do it before you publish. Okay, you have to give it away. You have to submit it to get a priority date. It should not be obvious extensions of other patents. And then after that, you get about 20 years of protection. But it's also important to understand that a patent is a public disclosure. So you can actually, once you patent it, everybody knows about it, right? And everybody knows about what you did. It's like a publication, and it's very, okay. And then, of course, we go through this dance. We go through a lot of dance of the claims. And the claims are important because if my patent applies to everything, and if people violate the claims, this is where you sue people and get the money in the US. One of the biggest things is licensing, and I really want to emphasize that. And that is, if you want to stimulate economic development, then what you do is you do a licensing for a limited period. Okay. If nobody's making any money out of it, licensing is free, right? I mean, or very like in the like here at UNM, our patents licensed for $2,500 so that they get started. You can also give everything open source if you want to be an academic like Nikos. Just say that it's used for non-commercial use. That's important. You have to say that. So then that way you can allow people to start using your technology, and then you grow it and grow your baseline. And then after that, if there's money to be made, you jump in with a lot of users. You can also give specific applications for your patent. For example, Signal Genetics doesn't want to go into, let's say, biomedical, but there is a little startup over there with Andreas Panagidis. They can license that technology. Andrea, go and hit all the hospitals. We don't want to deal with the biomedical, right? One of the most important thing, of course, is what is called non-exclusive licensing, right? You give people and you give them the chance to use your technology, but it's non-exclusive. I can also sell it to 10 different other people, right? This is what makes Microsoft. We had a museum here in New Mexico because Microsoft also started in Albuquerque before they moved to Seattle. And the biggest breakthrough, the one that made Microsoft was that they managed to renegotiate their contract with IBM so that IBM didn't have an exclusive licensing, right? It was non-exclusive. Therefore, Microsoft could sell anybody, right? That was a key point that IBM didn't care about. At the beginning, they wanted exclusive, like all of us want, but then they let it go, and now you see Microsoft, okay? When a startup starts, you want probably they want exclusive licensing, and my advice there is a limited period. So my final thoughts in the United States, just to say this, a lot of people think that if you have zero protection, no patents, no copyright, no trademark, you're not talking about them, then it's interpreted as zero IP. That means you don't have an intellectual property, right? You're basically doing a work for hire work, right? You don't have something fundamentally original. Right? keep your trade secrets quiet, right? Things very basic, things that could make a big difference if you give it to the right person. Copyright is very cheap. You can add a little C notice after you register, or you can do it before you register in the US. If you want to be a professor like me, then you open source. Just do it for educational and not commercial use, okay? If you really want to help the local industry grow. The other thing that shocked me is that patents are also very limited, right? I mean, I was looking at MATLAB, MathWorks. They only have 9 patents in China, 9, okay? They have 500 in the United States. So basically that means that if you do not have a patent that covers the country where you're at, they can steal everything. It's all theirs, okay? So if I'm operating, let's say in the UK, and my patent is only valid in the US, the UK can basically steal everything, and theoretically you're not protected. Not only that, but your patent disclosure in the US, they can use it to reproduce everything. And then, of course, I'm not a lawyer. please get somebody and pay the big bucks, because all I'm sharing is my experiences. Thank you very much. Thank you, Nico.
Thank you very much, Marios. Okay, we in the initial panel we had two persons named Tassos. Now we have 2 persons named Marios. So Marios Milis, I guess that you will have some questions for Marios Patikis after that, because I'm not very familiar with this. With the patenting and licensing and things like that. And to be
Fortunately, we have lawyers.
Anyhow,
for this.
okay.
You don't need me. You don't need me.
Let's start then by thank you, Marios, for sharing this experience. I guess things in US are more, although you didn't mention that, but I guess that in US the tendency for creating patents is, higher than in Cyprus or maybe in Europe. Well, let's go back to the theme of our panel, which is the market challenges for image and video analysis. Well, at least from the 2 first presentations by Betty and Tassos, I got the impression that what we really need is more accurate sensors, recording equipment, and things like that. So shall I kill myself for working, say, 25 years in computer vision and image and video analysis? So I don't know.
So no, Nico, sorry, I guess I let the first speaker speak. Sorry, let me stop.
No, it's open. This is the impression I got. I heard
so that's not
sorry,
true, right?
I heard Marios Milis also be a kind of more specific, referring to okay, we need we need clearly power and efficiency, and I understood that we also need to make sure that the algorithms we develop can be easily transformed to FPGA and hardware in order to run faster. But this is something different. Let's stay in my first impression. Do we really need better algorithms or better hardware at the end?
So remember that my example from Geisinger is free open source, a standard 3D convolutional neural net. You can download a few lines of, the model is only relatively a few lines of code. And that is done in the US to deliver healthcare to 3 million people. But that's what their target is, to use it as a product within the hospital. However, let me just share something from the US about large-scale video analysis. I told you what happens, right? So the students started working on it. What happened is that Google came in, doubled the salaries, and wiped out the whole team. And they are building their own biomedical. And so right now there's a transformation in the United States, in Silicon Valley, where the big giants, Amazon, Google, and even Apple are looking into medicine. So I think for large-scale medical video data sets, there is a trend. So let me stop.
So Tassos, any comment on this? Should we emphasize on sensors and equipment, I mean, okay, I guess that we should continue writing mathematics and publishing in transaction image processing, where Marios is the editor, and forgetting about any real application. If it's only a matter of sensors, I don't know. What do you think? And what about you, Betty?
For me, Nikos, is both. It's and sensors and the algorithms. And also what Mario said about the medical data is also the trustworthy, the explainability was also very important and gains a lot of ground now. Because first of all, about the sensors. If you have sensors of low quality, of course, you cannot interpret the analysis. But on the other hand, sensors of low quality are very useful in mobile application, you know, where we cannot support the use quality. On the other hand, you know what the trend of the big deep learning. If we don't have the algorithms, we cannot say so increase in object recognition, etc., etc. About the deep learning, I have made a proposal in the Greek proposal in 2011 about deep learning, and it was rejected because there is no novelty. Okay, 2011, where I think so that nobody knows what deep learning was. Okay, so
but you know, Tassos, you know, we will go back to deep learning later. I do have a question for that, but you know that the initial researchers working on deep learning and proposing by that time neural networks with many layers where I mean it was a humiliation for them at that time, saying, okay, but there is a theorem that say every function can be approximated with only three layers: input, output, and the hidden layer. So it appears that it was a matter of technology at that time also. I mean, and the many layers and the deep layers found eventually application. We'll go back to that, but let me also, Betty, am I right to say indeed that we should emphasize on, I mean, better scanning equipment for the Earth?
Let me comment on something. The biggest image processing consumer in Europe is European Space Agency. That is, I'm going to speak for Europe and not for the States at this moment, is European Space Agency, because is connecting all sensors, means that the new space is a trend and is connecting all kinds of sensors, means not only satellite sensors, but even images from terrestrial cameras, images from mobile phones, everything in a technological evolution that they call it new space. Means that inside this, you have to have good sensors. You have to have the capacity to get as much as faster big data. So this is the trend of the communication effort, and which is even the communication is a new space. It's space technology. The communication satellites, even for 5G, they connect. They are connected with systems that are on space. And this evolution, they call it in Europe, new space, means that this new space merges hardware and software and on board and inside, means on the Earth, and in our offices, in our houses, in order to facilitate our lives. So we do need better hardware, we do need better embedded software, means that inside the hardware, the software to be more sophisticated, we need to consume bigger amount of data in smarter and faster applications. So there is this artificial intelligence, deep learning, blockchain, how all those technologies can make our life to be easier. And this will be how these technologies will drive us the next years. The day before the TIFF event in Thessaloniki, because that was the first live event in Europe as international event, the day before, there was an announcement between the Greek government and the European Space Agency about the Greek microsatellites. And what the Greek microsatellites project is what I just explained, is microsatellites that this small constellation will give better images, bigger amount of data, for that on board there will be more applications. For example, when those microsatellites will acquire optical and not SAR and not thermal images over Cyprus, that the effect of the haze and the African dust is bigger. On board the system will correct it, on board the system will compress, on board the system will have the capacity to send in a smarter way the data to a terrestrial system that they are more dedicated artificial intelligence methodologies will run, and the end user will just have to push 2 buttons to get the information. Not in a sophisticated way, but just to facilitate the everyday life. So that's my understanding of the next 5 years, and there are always how to say possibilities to become better, and in the hardware and in the software.
So,
So in the United States, I can
feel-
share, Nico, if you want.
Yeah.
So there are two very, very big trends, just to build on what Tasso said. The first one is artificial intelligence, general artificial intelligence, machine learning. So right now, many universities are winning like $20 million grants, like left and right. I mean, I was on the panels. I think we gave out 5, and I think there was another 5 before. So the big trend is AI. And when I say big, I mean, last week I was in a panel how to teach it in middle school, since literally K through 12. In high school, we're not talking even, that's how important it is for the US. They won't, and then of course there is a competition there with, you know, at one point there, I was hearing voices about, oh, you know, look at Russia. Russia is interested in AI. Now, of course, it's mostly about China. The second very big thing is quantum computing, which it's the amount of resources that the US is putting. We hired 2 professors here at UNM. We are a tiny university. We're bleeding. We just got 2, and we established our own. And then, of course, to build on Betty as well, the greatest president who ever lived for all generations, who just recently didn't win a re-election, established the Space Force. So I'll make you fun. So basically, Mr. Trump established the Space Force. So now we have the Space Force in the US. I don't know where it's going. I think Betty might know more about it. But again, quantum computing and AI.
I agree with you, Marius. You know, quantum computing, because you know something that I was suggested to make a PhD on quantum computing before, you know, 20 years. Okay, and probably it was too early at this period to make it. But I think so because I have also. Involved.
But let me.
How
that's
this, so this is also an important theme, you know, to think about.
I mean, okay, we're discussing again let's go back. Image and video analysis, emerging markets. And okay, I heard Mario saying, okay, in US, the future is AI. Okay, we all know that. And quantum computing, okay. But how these two are really related with what we know as video or image or video analysis.
Because
And I also sorry, I also heard Betty saying, okay, poor professor, I'm sorry that you worked 25 years in this domain, but look, now don't be sad. It's okay. There is some future, okay, for you as well. Yeah, there is. I mean, I don't know what is the quote in English, but it's something like making the pill gold, Chrysonoto happy in Greek. So, and okay, I will come again to Marius and Betty and say, imagine that you are going to hire a new employee. And what do you prefer? One that is able to transform existing algorithm, AI, image processing, whatever, to be run by hardware, FPGAs, and things like that, or a guy smart enough to develop new algorithms?
So those are two different. Sorry.
Sorry, Marius.
Sorry?
Okay.
I couldn't hear you.
To be honest, can you hear me?
Yes, now it's.
A smart person that is involved in software development can be a smart person that this software will be embedded in the hardware. Means that when we try to hire a new person, we would like to see in this new person that this person has a vision. And if somebody has a vision, I think can make always think good things to happen. That's a wording. It's a Greek wording in English. So I think that's the commercial company's task, to find a person qualified but with vision.
Marius, honestly, I know you are engineers, as I said before, trying to fix every detail for a real product. Honestly, I mean, Marius, really sorry, Marius. Honestly speaking,
Sure.
Would you prefer one that is possible to read an algorithm in a paper and transform it into FPGA code, or one to develop new algorithms?
Okay, for sure, developing new algorithms is the new technology is very important. But okay, we mainly focus in translating these technologies and be able to embed, to make a product. So if by taking one ready technology or to improve some technology in order to be able to be embedded in a product, we prefer this than start from beginning and have a product in 10 years, let's say, or in more.
This is the difference between academia and commercial life. Means that in academia, it's much more, let's say, logical to start from the scratch and make something brand new. To spend time to design, to evaluate, to demonstrate, to pass all the TRL levels. And this is part of the academic life. In the commercial life, we have to start from something that it's mature enough in order, in a smaller time, to have it out in the market. Even in those, let's say, points that I described, we prefer to collaborate with the people that, as I told before, they have a good will and a vision.
Marius Patikis, I'm coming to you for a very specific question. Actually, two.
Go
Actually, two.
Go ahead. So,
Actually, two. The first one, I know that you're working for many years in biomedical application. You already mentioned that before for many products, patented and so on. Well, and you mentioned before that AI is the future in US, one of the two main highways, say, of research. Okay, it seems that nowadays AI means deep learning. And we all know that deep learning is also a very, 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 very black box. And I know that you have been working with doctors and etc. So how easy is to cope with that? I mean, to provide to doctors a black box and say, okay, this is the outcome, and you have to believe it or you have to accept it or whatever. The second question is that I know you are serving as editor in transactions of image processing. How often do you receive papers related with actual industry applications of image processing?
okay, so let me start with the first one. I think it's easier. So, so yes, explainability is a very big deal. So for the paper that I have described, I did not show you. Yeah, we got a lot of questions about explaining yourself. So what we did is, what the student did is, and what most people do is create a local model where you basically, once the model was done, you put a bunch of black pixels over the input, right? And try to figure out where do you get the best response on the other side. This is the method that was developed with our student. And what came up, of course, was that the cardiac walls had a huge impact, the ones failing. So there is a lot of, I mean, as I said, I'm just going to say this again, I'm sorry, but we're
There is
talking
a strand
about...
of research in European Union supporting many projects on explainable AI. I know that. Yes.
Okay, so yeah, so we have about, so the theoretical is going to happen. On the second side, what do I get? Wow, most of the papers we get are universities for sure. However, the universities are, at least, and most of them are Chinese. I mean, the ones that I see, most of them are deep learning, mostly, and China is way ahead. I mean, and then what happened in image processing, we saw that the total rise of China in transactions on image processing, where it was, I think the acceptance ratio for papers from China was at maybe around 10 or 20%, and now it's like exactly the same as a paper from the United States. And I will even say that in certain areas like deep learning, they completely dominate. Now, I think there's, so I don't think the situation is as black and white as it is in Europe, in the sense that, for example, just to give you an idea, the majority of my students get internships. And before they graduate, and I strongly encourage them to leave me. This is especially easy for international students. They can leave me, but they have to come back and complete their degree. So it's great. So they basically, so we have students who end up working at Intel and Apple, and they really grow over there. They kill them. Sometimes they work them day and night, especially Intel is very famous for that. And then when they come back, then all of a sudden they become more productive in the academic world. So I think I would love to see that more in Cyprus, where people at the University of Cyprus start working with Marios Milis at Signal Genetics or Betty over there in geomatics, and just throw them in there for a I don't know, a semester or a summer, and under the supervision of qualified people, and that way you get we're a little bit more in line. Let me just say that.
Okay, thank you, Marios. That's all. Well, when I was assigned to assign this panel, and I saw the theme, I was thinking to change it a little bit. I didn't do that, but the question is, what is the future of image and video analysis after deep learning? Or to make it a more challenging, is there any future in image and video analysis after deep learning? And let me just express a little bit my personal view on this. I used to work in face recognition and facial expression recognition. My PhD was on that area. And now that I see in YouTube school students, 15-year-old, to program an application and solving something. I wrote a lot of papers on feature extraction, which are the best features, are SIFT, are transform based, are holistic, whatever, blah, 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 blah. And after that, deep learning came. So is there any future in image and video analysis after that?
Really, I don't know what's the future, but I think so that one major future is to make the AI explainable. This will be trigger the future of medical imaging for sure, because you know, it's like Terminator. If you cannot trust the robots and the intelligence, then they can make the doomsday. Do you remember the film? So this is for sure very important. It's also important for the social part, because as you know, we are engineers and technical guys, but the world is governed by the social guys, meaning that the lawyers, you know, how it's going to trust us, all these things plays a very important role. So I think so that this will be open a very big chapter, and we can see papers in CVPR in a few years all about explainability and things like that. This is what I understand. And also, if you see the new call of Horizon Europe, this is the most important part is trustworthy AI and how we're going to make the human.
But also, is this a field really related to image and video analysis? I mean,
yes, it's related.
You know that I can remember some early effort in trying to make the neural networks explainable, and the introduction at that time of fuzzy neural and things like that, which unfortunately or fortunately died after some years. So the question is this really something that requires a deep knowledge of image and video analysis, the image and video processing, computer vision techniques? Is this necessary? Anyone can comment on this,
Nicolas,
not only Tassos. I mean, Marios, you're welcome. Marios,
when I was young, Nicolas, just one minute. When I was young, I have read the paper, Artificial Neural Networks Black Boxes. Because I remember in transaction neural networks, because I remember, and I just searched on Scholar Google, find it in 1997, okay? And it has received only 567 citations, okay? So I think so that it was, of course, the first approach, but at this period was too early. Now the approach is more systematic. You know, it's, how to say, more coordinated. So if you see something, because deep learning was also exists, you know, many years. Everybody knows that the neural network can have many layers. And if you see, for instance, the paper, the speech of Lenkun, he said that initially he have sent the paper of convolution neural networks to CVPI. He was rejected, and then he sent it to ICAPS because it was a second class conference, and then he was accepted. Who knows?
I had attended the speech of this guy during the ICP in Vancouver. I think it was 2010, 12. I don't remember exactly. Yeah. and he told us the whole story of that. That's why I remember it.
Yes, so I have also said another speech of him in Calgary, but the situation is not this. The condition is that when something is doing for you alone, you are the only guy that you're dealing with quantum computers. Nobody cares about you.
It was a matter of technology, I think. Anyhow, I mean, you know that training neural networks at that time with a single hidden layer, trying to converge and things like that, took a lot of time in most cases when we are dealing with images with a lot of pixels and things like that. Imagine that we had to care with, say, 60 layers as now. So this is something that we take into consideration. I maybe the technology was premature at that time in order to allow deep learning to be useful. Marius, do you have any comments?
Nico, please allow me to give one example. I was following the IEEE imaging lecture 2 weeks ago, and the General Electric healthcare medical imaging head, I cannot recall the name, apologies. They plugged in the pre-processing module in their portable MRI scanners based on deep learning. They replaced the maths with a deep learning module that has better quality images, and most importantly, it makes the scans faster. And you know, makes the scans faster means money. I mean, deep learning is embedded in hardware products, and it will have more impact, I think, than we have thought of. I mean, look at our conference. It's a very simple conference on images and patterns, and I think more than 60% to 70% of our papers throughout the world deep learning.
Okay.
Yeah, but this is a this actually was a question.
Yeah. So
I
this
mean,
is a
yes,
question that
if in a Caip conference we are discussing about deep learning all the time, is there any future in image and video analysis at the end?
I think it is. Okay. So the solution. Let me just say something that I actually brought up literally in a big panel, and I said with 200 professors there. And here's the problem. The reason people were so reluctant to jump into deep learning, and the reason it's so biased, is because the data sets are basically Google. Okay, Google, YouTube, and Facebook. Okay, so what we found, and you can see it in our papers that we submitted to Caip, is that if you start focusing on a real problem that is your problem, like, you know, we've got thousands of hours of videos, then you could destroy the deep learning methods by incorporating them in there, and by adding things like, the student we just presented, change the frame rates, look at projections, just simple ideas from image and video analysis, and you ended up with, I think the last presenter, I think Fong showed it, 12 times faster, 10 times more accurate, right? Things like that. So deep learning is going to be something that every student must be trained on as a first approach for right now. But then, again, in my experience, when you have a real problem that you understand well, simple things that come from your experience, Nico, like, understanding your problem, you throw the deep learning in there just to make sure you keep your methods in check. But I guarantee you that a very simple idea that you will come by looking at the data for your problem will have a much bigger impact on your problem than trying all the deep learning methods that have been developed, including face recognition, which is what the example that I talked about was face recognition. What I think we should do is that what I would do is to encourage people to build their own video image data sets, probably more video. On the video side, I can tell you for sure, the video is completely open. Okay, the image, finding things in images, I think they really nailed a lot of problems. When it comes to video, people come in and out. I gave in the tutorial on Monday. You have to re-identify them. They change, like, for example, and I'm sorry, I'm repaying my student Fong. you can solve the complete occlusion here. It's me, because you processed me and you know from the previous frame it was me, right? So that's a history issue, right? So I think video is here to stay. And then again, to answer your question, a lot of the students we produce ended up in working for self-driving cars, competing against Tesla because they hate the founder of Tesla. So for video, the answer is yes. For images, we are in trouble.
for image in the future. So we are very close. I mean, 1 minute is left according to the schedule. I love this discussion. I don't know, Kostas, I would like to repeat it in the next Caip with the same person. I like it very much. I apologize that I need to stop it. And I would like to thank you all for being with us today for this discussion. And I don't know if you need to add anything for say two words or something. Otherwise, we will pass the floor to Kostas to continue. Just I mean, that's all. I think that your early paper on I don't remember the name on retrainable neural networks seemed to me a great opportunity to consider with transfer learning nowadays.
Actually, Nikos, because and now I'm trying to find out this. The retrainable neural networks 2000.
Yeah, I mean, transfer learning is
Actually,
in the future.
it's the same with continual learning, not continual learning. If you see the new article of continual learning, CVPR, and my paper in the retrainable neural networks is exactly the same.
I mean, I propose you to republish it as retrainable neural networks revisited. Anyhow, thank you very much, all.
Thank you.
Thank you. Yeah, one final note on the retrainable, Daso and Nico. So one of the first things we realized is that when we threw a very tough problem, so you have these, let's say, deep speech or whatever. So when you throw a very tough problem, they fail. So what I am asking my students to do is to run the deep learning, okay, commercial, whatever, figure out where it fails. And then we start there. We don't even start until we know where they fail. So I just the closing thought. Thank you, Nico, for reminding us.
Okay, I think I will repeat this session in 2 years' time from now. So I reserve you from today. Kostas, I don't know if you can hear us. I think that we have concluded this session. So
Thank you very much.
Kostas, let me check who is next in the program. We have 10 minutes break, and then Antonio Greco is chairing the Guess the Age contest. So thank you very much for being with us. 10 minutes break, and we'll come back for the next session.
Bye-bye.
Thank you for the invitation. It's a very, let's say, nice event, and see you again in the round table in 2 years.
We are always glad to be with you.
Thank you very much, guys.
Thanks, Nicola.
Thank you.
Thanks.
Antonio, hi.
Hi.
So the floor is yours. We have a very, very stimulating session now. So Antonio, please, I mean, go on.
Okay, thank you very much, and also thank you very much as organizer, one of the organizers of the conference, for giving me the possibility to organize this contest. So I just share my screen. You hear me well? So no problem with the audio?
Yes, perfect, Antonio, thanks.
Okay, so I start sharing my screen. Do you see my screen?
Yes.
Okay, so maybe I can start, maybe I can move this somewhere else. Okay, so in this session, I will, this session is dedicated to the Guess the Age contest. The session will start with the presentation of, let's say, a resume of the results about the contest, some information about the contest, and then there will be the presentation of the 4 papers associated to 4 methods which participated to the contest, namely real-time age estimation from facial images using YOLO and efficient net by Giovanna Castellano, Berardina De Carolis, Nicola Marbulli, Mauro Sciancalepore e Gennaro Vessio. Then single view facial age estimation using deep learning with the cascading random forest by Imad Edine Tubal, Lin Kuan Liu, Dan Lin, Kannappan, Palaniappan. Then age style augmentation for facial age estimation by Yuan Lin, Jeser Zhu, Xiao Tang, Ziting Chen, MD Chopon, and Marina Gavrilova. I hope that the pronunciation are correct. And finally, we will conclude with the LAE, long-tailed age estimation by Zhengao Bao, Zichang Tan, Yuzu Junwan, Xibo Ma, Zhenlei, and Guodong Guo. I just want to remind that we have 8 minutes for each presentation. I kindly ask all the presenters, all the speakers to stay within the 8 minutes. And after all the presentations, we will have time for having a discussion, so for questions and so on. So I will start my chronometer for my presentation. And okay, I'm Antonio Greco from the Media Lab. That is a laboratory in the Department of Computer and Electrical Engineering and Applied Mathematics of the University of Salerno. I'm an assistant professor, and I am the organizer of the Guess the Age 2021 age estimation, Guess the Age 2021 age estimation from facial images with deep convolutional neural networks. In this presentation, I just want to resume some information about the contest. Namely, I will present the contest task to all the participants. Namely, and then I will present in briefly the contest teams. Then I will leave them the possibility to describe their methods. Then I will present the results. So I will give the final results of the contest, and finally I will conclude the presentation with some comments about what we learned by this contest, from this contest. So let's start with the contest task. In the contest, in the Guess the Age 2021 contest, the goal of the teams was to training a deep convolutional neural network for age estimation from face images. This neural network had to achieve good performance in terms of accuracy, namely the error in the age estimation, and regularity, namely the error must be equally distributed in the different age ranges. And the teams which participated in the contest had to respect 2 main constraints. First of all, they were allowed to use only for training only samples from the provided training set, namely the media age dataset. And then they were allowed to propose a method based on a single neural network. So ensembles were not allowed. As for the dataset it consists of more than 500,000 images of more than 9,000 identities from VGG phase 2 that have been annotated recently with age labels through a knowledge distillation approach. As you can see from the chart, the images available for each age group are not balanced. We have very few samples under 20 and over 60. So this imbalance is something quite normal, quite typical in the training of age estimation methods. For this reason, we asked to the participants to design methods that were as accurate as regular, so that in order to deal with this imbalance. How to evaluate the accuracy and the regularity. The accuracy has been evaluated through the standard mean absolute error in order to evaluate the error on each sample and then the average of all these errors, while the regularity has been computed by using the standard deviation, computing the MI in 8 different age ranges, namely 1, 10, 11, 20, and so on. And finally, the index, the performance index that was used to evaluate, to have a ranking of the methods is the age accuracy and regularity. That is the sum between the maximum between 0 and 7 minus MAE and plus the max between 0 and 3 minus standard deviation. What does it mean? It means that if a method has a very, let's say, bad accuracy and bad regularity, namely a MAE greater than 7 and the standard deviation greater than 3, obtain an AIR equal to 0, while a perfect method with MAE equal to 0 and standard deviation equal to 0 achieve the maximum AIR that is 10. Of course, the methods typically achieve intermediate values of MAE and standard deviation, so intermediate values of AIR. The method which achieved the highest AIR was the winner of the contest. 20 teams sent an official request for participating to the contest, but at the end, from all over the world, and also a request from the academia, so only one from a company, all the requests from academia, while at the end, 7 teams participated to the contest that I reported here in alphabetic order, namely BTWG, Siva Lab, GOF, GV's ULE team, Levi, Pacific of Artificial Vision, and Vision Hackers. I will not give you more details about the methods proposed by the teams because they will have the time after my presentation to present to describe their methods. I was really undecided if the results to present the results in this presentation, because in the closing remarks there will be also an awards ceremony for this contest. But since I sent the results on the test set to all the participants, so the results of their teams, they still don't know the final ranking, I decided to anticipate the results so that I can also comment about some results. So drum roll for the ranking, and we'll show the last four places in the ranking. So the 7th position was achieved by the GV's ULE team. The 6th position was reached by the GOF team. The 5th position by the Vision Hackers team that will present their paper after this presentation. And the 4th position was achieved by the Levi team. Just a moment of pathos for the third position. The third position was achieved by the Siva Lab team with a great 6.97 AAR with the MI close to 2 and a very low standard deviation, so demonstrating a very good accuracy and regularity. But now let's see the first and the second place. We have two teams in alphabetic order, BTWG and the Pacific of Artificial Vision. The winner of the GTA 2021 contest is the BTWG team with the AAR of 7.94 with the MI of 1.86 and the deviation standard deviation of 0.20. While the second place was of Pacific of Artificial Vision with the AAR of 7.55, MI of 1.84, so very accurate, but just a little bit lower standard deviation of 0.61. So congratulations to all the teams, and especially to the teams which are on the podium. The performance are great, as also confirmed by the specific analysis of the various of the MI achieved on the various age ranges. As you can see, the first three teams were able to achieve a MI of around 2 for all the age ranges. The difficulties were on the first age range, namely between 1 and 10, and this was the difference probably for the winner of the contest. So if you consider that the average MI of a human is around 3, the performance achieved by the participants are really great. So my congratulations for these great results. Just to conclude what we learned about, without knowing the methods, just two things. I could conclude that custom loss and training procedures have been very important for BTWG, Pacific of Artificial Vision, and Siva Lab, because they achieved a good accuracy, but also a great regularity in their methods. The method based on the method designed for trading long-tailed distribution proposed by the BTWG team was was able to achieve a very good trade-off between accuracy and regularity. But also the AAR inspired loss function proposed by Siva Lab and the custom loss function designed by Pacific of Artificial Vision team proved to be very valid solutions. While we have to say that data augmentation seems to be not enough, since methods that did not customize the loss function, the training procedure for taking into account the imbalance between the samples in the different age ranges, were not able to achieve the same performance as the best teams in the ranking. Just to conclude, I wanted to advertise that there is a special issue that is not linked to the conference, but I'm one of the guest editors. The submissions will be open from tomorrow, by tomorrow. So it is a special issue on ambient understanding for mobile autonomous robots in the Journal of Ambient Intelligence and Humanized Computing. So you are encouraged to. I encourage you to submit some of your papers about these topics, because phase analysis is one of the topics of interest, of course, for mobile autonomous robots. Thank you for the attention, and I leave the floor to the first paper that has to be presented, namely real-time age estimation from facial images using YOLO and EfficientNet by Giovanna Castellano, Bernardina De Carolis, Nicola Marbulli, Mauro Sciancolepore, Gennaro Vessio, from the Department of Computer Science of the University of Bari Aldo Moro from Italy. Who will be the speaker? Nicola
Me.
Marvulli?
Yes.
Okay.
Do you hear me?
Yes, yes, very good.
Okay.
Can you share the screen, please?
Yes. Okay. Do you see the presentation?
Yes, full screen now, but probably okay. Okay, you can start, Nicola.
Thanks.
Thank you.
So, good afternoon. I'm Nicola Marvulli, a student of computer science at the University of Bari Aldo Moro, and I would like to thank my colleague Mauro Sciancalepore and my professor Giovanna Castellano, Berardina De Carlis, and Gennaro Vesso for the development of the work related to real-time age estimation from facial images using YOLO and EfficientNet. So the aim of our project consisted to create an automatic age estimation system which is able to predict the age of a person given a simple facial image. So as you can imagine, this is a difficult task for humans. For example, if we consider two persons with similar facial features, it could happen that they can have different ages. So this kind of system could also be beneficial for real-time, real-world application, for example, in the security field or in the marketing field. So it is noted that the main state-of-the-art models for age estimation are ensemble models, but they are characterized by complex architecture and they require great computational resources. Given that our main focus is the efficiency of the models, we have decided to use a single neural network for the estimation, which is suitable for real-time applications. So our system is composed by two main components, which are face detection model and age estimation model. For the face detection, we have decided to use ULV5, which is the main state-of-the-art of the object detection. In particular, we have decided to use ULV5S, which is the slight version of YOLO. For the age estimation, instead, we have tested a series of models taking some inspiration from papers. We have started from a convolutional linear network starting from scratch, and we have also tested state-of-the-art models, for example, ResNet 50 and EfficientNet B0. At the end, we have decided to use Efficient B0 because it has totalized the best results. We have trained the ULV5S on a subset of wider face dataset. This subset contains 2200 images, and we have decided to use this subset in order to make the training faster. So instead, for the age estimation, we have used the MIVIA age dataset, which is the dataset of the challenge, and we have taken into account only the images which have resolution greater than 30 by 30 pixels. So as we can see, we have an unbalanced data distribution. That's why we have decided to use a data augmentation technique in order to face this problem, which are image rotation, image translation, and color calibration. So for the experimental setting, we have used Google Colab for the training of both models. And after a series of tests, we have seen that the best hyperparameters for the face detection are mini batch size of 32, learning rate of 10 to the power of -2, and Adam optimizer with default values. So the metrics adopted for YOLO are intersection of a union and mean average precision. Instead, for the estimation, we have used mini batch size of 128, learning rate of 10 to the power of -4, and Adam optimizer with default values. The metrics are the metrics of the challenge, which are mean absolute error, regularity, which is the standard deviation, and AAR, which summarizes the previous metrics. So as we can see, we've tested a series of models for the age estimation, and we can see that our best model is efficient V0, which has totalized an AAR of 6.80 on our testset. Instead, this model has totalized an AAR of 5.41 on the testset of the challenge. So at the end, we have created the edge guesser system, which is a system written in Python. It is a web app, and it is composed by two main modules, which are face detection and age estimation. So this system takes a stream of images from the input source, which is the webcam. And so the face detection extracts the faces from these images, passes them to the age estimation module, which is EfficientNet. And this module predicts the ages of these faces and returns to the client a JSON composed by the bounding boxes, the face confidence, which is a score between 0 and 1 computed by YOLO, and the age, which is the age predicted by EfficientNet. So these are examples of the runs of our system, both on static images and on real-time images. So on the left side of this slide, we can see an example of a real-time image. At the top of the bounding boxes, we can see the age predicted by EfficientNet, and below the images, we can see the real age of the persons. At the center of this slide, we can see also an example of static images, and on the right side, you can see also an example of static images of static image. So at the end, we can see that we addressed the problem of the age estimation, focusing on the efficiency of our models. That's why we decided to use YOLO v5 and EfficientNet in order to create a system which is which can have a good result on real-time performance. So for future work, we will want to integrate more advanced data manipulation technique in order to improve the system stability. Thanks for the attention.
Thanks, Nicola. Congratulations for your results, and thank you for respecting the scheduling. So please stay in the room, because after the presentation may be some questions for you.
Yes.
I leave the room to the second paper, namely single view facial age estimation using deep learning with the cascading random forests by Imad Dinetubal, Lin-Quan Liu, Dan Lin, Kannappan Palaniappan from the Department of Electrical Engineering and Computer Science, University of Missouri, Columbia, USA. Who is the speaker for this group?
I'll be presenting.
Hi, Imad. Nice to meet you.
Nice to meet you as well. I'll need to share my screen.
Yes. Maybe Nicola can. Are you able to share your screen, Imad?
I cannot. I think the current presenter needs to stop sharing.
Okay. Please, Nicola, can you remove the sharing? Okay, thank you. Okay, Imad, you can now.
Okay. Are you able to see my slides?
Yes, perfectly. You can start if you want.
So hi everyone, my name is Imad, and I'll be presenting our paper titled Age Estimation, Single View Facial Age Estimation using Deep Learning with Cascaded Random Forests. So the rest of the presentation is recorded, so I'm just going to go ahead and play it. In addition to the unbalanced distribution of the dataset, some of the challenges we found are the following: occlusion, filters, bad cropping, low resolution, and accessories. But just making sure you can hear my audio.
Yes.
Let me. In addition to the unbalanced distribution of the dataset, some of the challenges we've found are the following: occlusion, filters, bad cropping, low resolution, and accessories. Below are our predictions for these challenging phases. We will explain our approach and how far we are from the real ages in the coming slides. Paying close attention to the distribution, we made sure to create our own training and testing split based on the provider training set. The training set we created is composed of 90% of the total training data, whereas the remainder 10% is used for testing or evaluation. During the split phase, we made sure to preserve the original distribution of the dataset. Part of the created training set was also used for validation when training our deep neural networks. One pre-processing step that we experimented with is facial alignment. As you can see in this slide, this step aligns the face to create uniform pose for all of the subjects. The way we were able to achieve this is by taking the input image and running it through a face alignment network cited below. This network predicts the pose of the input face, or the landmarks. We then use these predicted facial landmarks as well as the target front-facing pose landmarks to estimate the transformation matrix. This transformation matrix is then applied to the original face to align it to the target pose. In theory, face alignment should reduce the complexity of the task for the neural networks to learn age. However, after conducting our experiments, we've discovered the following. Face alignment reduces the pose distribution of the face, which has an opposite effect of data augmentation, which in turn hurts our training. Face alignment fails inside profiles where parts of the face are simply occluded. And finally, the applied warping can greatly reduce the image detail. So then we decided to move forward without facial alignment. Instead, we propose simple data augmentation techniques as follows. First, we apply random rotation and flipping. We also apply random erasing to battle the pixel attack problem. We randomly apply intensity change and randomly apply black and white filter. And finally, we apply random Gaussian blur as seen in this slide. The deep neural network of choice for our method is ResNext 50. We leverage the ResNext block that introduced the concept of cardinality. Increasing the cardinality has been proven to increase the accuracy in classification without increasing the width and depth of our networks. We can take advantage of this accuracy improvement to make better predictions for our underrepresented age groups without decreasing the model complexity, which would result in overfitting. We define a custom loss function for the task of age estimation inspired by the AAR metric. The proposed loss function is composed of two parts. First is the soft L1 loss that is inversely proportional to the age accuracy. The second term is the regularization term, similar to the one in the AAR metric. Both of these terms are weighted using parameters gamma and lambda. Our first set of results show the advantage of our custom loss function. First, we show the results of our own evaluation set. The x-axis represents the age group and the y-axis represents the mean absolute error for that age group. We compare the performance of ResNext trained on the more popular MSE loss versus our own proposed AAR loss. In green, you see our results on the hidden test set for both loss functions as well. Some of the takeaways are first, the AAR loss improves the prediction accuracy in all age groups. Our model performs worse on underrepresented age groups, which is expected. We also show some numerical results in this table below. To battle the imbalance problem, we experiment with deep imbalance regression proposed by the cited paper below. When training with imbalance regression data, the label density distribution doesn't correlate to the testing error very well. Label distribution smoothing convolves a 1D smoothing kernel with the label density distribution to increase the inverse correlation with the testing error. This gives us better loss weighting per training example when we train our networks. Again, we show our results on our own evaluation set as well as the testing set. We can see that overall the performance did not improve in evaluation and the hidden test set, and it did not solve the problem of age imbalance. Here is a table for some more numerical results. Looking back at our architecture, ResNext uses a series of convolution to generate a feature vector that is fed into a fully connected layer to generate a prediction. We first try and replace the fully connected layer by something more powerful like a random forest to see the added advantage. Next, We also use a similar method using 2 layers of random forest. These 2 layers work as follows. First, the first layer is classification random forest. It takes the feature vector as input and produces a class output representing one of the 8 age groups. The second layer takes as input both the deep features as well as the age class probability map as input, then uses a regression random forest to make a final age prediction. Here we show the results for our evaluation set for plain ResNext with a single regression random forest, and ResNext with our proposed 2-layer random forest. Again, we show the same metrics for the hidden test set as well in green. Some of the takeaways are, first, the single-layer random forest did not improve the scores. The 2-layer random forest outperforms the random forest consistently, although it has comparable results with plain ResNext. This table shows the results of our 3 main methods for both our evaluation set as well as the hidden test set. Although the plain ResNext has the best AAR score, ResNext with our proposed 2-layer random forest scores better in sigma, which indicates better stability and generalizability in the underrepresented age groups. Here we show the subjects introduced in the beginning of the presentation, their real ages, and the predictions of the different methods we proposed. To further show the generalizability of our model, we tested on 2 internet trendy pictures. The first is from a video of Mark Zuckerberg and Bill Gates sitting together. This video was taken in 2017. The second picture is a picture of Angela Merkel taken a few weeks ago. Here are more examples of the age progression for both Steve Jobs and Bill Gates, which are the same age. Thank you for your attention.
Thank you, Imad. It was really nice, especially the last part, and I completely agree with you with some of your observations. Please stay in the room, because at the end maybe you can receive some more questions. Thank you very much, and let me leave the room to the paper Age Style Augmentation for Facial Age Estimation by Yu Hong Lin, Je Sen Su, Kiao Tang, Ziting Chen, MD Chopon, and Marina Gavrilova from National Taiwan University of Science and Technology, Taiwan, and University of Calgary in Canada. So the speaker should be Yu Hong Lin.
Yeah.
Do you hear me?
Yes. Can you hear me?
Okay. We hear you. Can you also share your screen and, if possible, activate your camera?
Okay. I'm setting my camera.
Okay, we see you.
Yeah.
You can share your screen as soon as you are ready.
So it's
okay, I see your slides. So you can start when you want, when you're ready.
Okay. Thank you. Hello, everyone. So I'm Yu Hong Lin from National Taiwan University of Science and Technology. And today I'm going to introduce the age style and alignment augmentation for facial age estimation. And this research was in collaboration with researchers from the University of Calgary, thanks to the advice and guidance during the research process. So the competition provides a very interesting age dataset. This dataset composed of more than 570,000 images in different face size, facial pose, illumination conditions, gender, and ethnicity. This feature makes the dataset is dependable but also very challenging in age estimator work task. Then we hope to have a good performance in every age group. But the distribution figure shows that there is a huge difference in the number of images between the middle age groups and the side age groups. We think a model developed upon this imbalanced data often leads to bias estimation. The performance in the side age groups may not be good as the middle age groups. Due to these 2 challenges, we propose 2 data augmentation approach and using a well-designed age estimator model to verify our method. So first, to reduce the influence of performance from facial size and facial pose, want to keep other features of the advantage of the dataset. We decide to use alignment data as augmented data. We easily use face alignment network, which is constructed on a stack of 4 hourglasses network to detection face landmark points. According to the main 5 facial points, we not only rotate 2 eyes points horizontally, but also set a distance between the midpoint of eyes and the midpoint of mouth. We do alignment work for all the data in the dataset. In order to solve the problem of imbalanced data, we produce an edge transfer generative adversarial network, which we call edge style GAN. The edge style GAN has the following component. We have an encoder-decoder type generator. And to assist the training of the generator, we need to have 3 assistant networks, which we'll introduce later. The main generator is made of an encoder and a decoder. The input of the encoder is given image, which is to be transformed in the edge and keeping the same identity in the output. To assist the training of this generator, we need to have a facial identity extractor C, which is made of ArcFace, a state-of-the-art face recognition system, and a discriminator which will be able to check whether the generated quality is close to real images. And we also have this multi-test classifier MI to check if the edge generator can appear as the real target edge. So through the edge transfer generative adversarial network, we can use images from media dataset to generate other edge images. We can see our augmented image in the blue part of distribution figure. We finally augment more than 74,000 images in young age groups and more than 69,000 images in old age groups. Then is our edge estimator. We use ResNet 50 as our main structure. The model will predict the edge probability of input image. We use mean variance loss to assist during training process. It is confirmed very effective to edge estimation. The mean variance loss is composed of 3 loss functions: cross entropy loss, mean loss, and variance loss. The cross entropy loss is very useful for this classification task and helps to improve training stability, convergence, and efficiency when composed with other functions. The mean loss aims to penalize the difference between the mean of an estimated edge distribution and the ground truth edge. The variance loss is used to penalize the dispersion of an estimated edge distribution. So we divided the dataset into 81 edge groups with 1 edge interval, and employ 90% images in each edge group as the training data, and the remaining 10% as our testing data. We set 4 training datasets from this training data to verify our theory. The first row is original data. The second row is aligned original data. And the third row is combination of original and aligned images. Last row is edge augmented images with above images. So you can see our training data number here. So here is the performance we got from these training settings. We can see the performance of the 4 different training materials in the AR score from table 1. As our data augmentation, we can see that the performance is getting better. In table 2, you can see that we compare the performance of each edge group of whether they are an edge augmented image. The performance got better in those edge groups who have an edge augmented images. Table 3 shows the final score we got from the contest testing data. So to conclusion, different from the common image-based data augmentation, we propose a GAN-based data augmentation to handle the edge data imbalance situation. The proposed edge style GAN can generate face with desired edge intervals and keep face identity, and is verified by facial edge dataset. And the proposed approach that combines the edge style GAN and FAN-based alignment is verified effective on the GTA contest. So thank you.
Thank you, Yuong, for your very clear presentation, for respecting the scheduling. So please stay in the room for any other questions after the last presentation.
Okay.
The last presentation is the paper LAE, Long-Tailed Edge Estimation by Zhengao Bao, Zichang Tan, Yu Zhu, Jun Wan, Xibo Ma, Zhenlei Guodongguo, sorry for the pronunciation, and from various institutes in Beijing, China, namely Institute of Automation Chinese Academy of Science, University of Chinese Academy of Sciences, Institute of Deep Learning Baidu Research, and the National Engineering Laboratory for Deep Learning Technology and Application. Zhengao Bao, nice to meet you. I see your camera, so when you are ready, you can share your screen.
Okay. Can you see my screen?
I see your screen, so when you are ready, you can start.
Okay. Good afternoon, everyone. My name is Zhenghao Bao, and from Institute of Automation, Chinese Academy of Sciences. Today, I would like to present the paper of LAE, long-tailed age estimation. At first, I would like to give a short introduction to our work. This work is about facial age estimation. The goal of facial age estimation is to infer a person's age by giving a face image. Just like these two examples, judge the age from the face image. Most of the existing works train feature extractor and classifier at the same time. For example, most deep methods like DEX usually train these two as a whole model. However, we consider that training feature extractor and classifier as a whole is suboptimal for age estimation. It is because long-tail distributions are prevalent in age datasets, and the resulting model usually performs poorly on tail classes, usually in children and the elderly. The couple representation learning and the classifier may be more effective. This is our observation. Next, I will introduce our approach. In our work, we build a strong baseline for the representation learning stage. It contains three main promotions, including model architecture, pre-training, data augmentation. First, we use EfficientNet v2 as a backbone of the feature extractor. Compared to the ResNet models, EfficientNet v2 has a faster training speed and better parameter efficiency. Second, pre-training has a significant impact on the performance of an age estimator. Before training the network on age datasets, we pre-train the model on MS syllable 1M, with only using identity labels. In this way, a large number of face images are employed to obtain a good representation for face recognition. Third, data augmentation is capable of enhancing the size and the quality of training datasets to avoid overfitting. We apply rand augment as data augmentation. Following the work, age estimation using expectation of label distribution learning, the model is trained with a KL divergence and L1 loss. In the classification stage, we freeze the model except for the classifier and train on balanced MIVIA obtained by class-balanced sampling, which means each class has an equal probability of being selected. One can see this as a two-stage sampling strategy. where a class is first selected uniformly from the set of classes, and then an instance from that class is uniformly sampled. Moreover, we introduce MSE laws into this stage for further narrowing down the standard deviation of different age groups. That is our approach for long-tailed age estimation. Next, I will present the experimental part. Since the test set is not available during the competition, we randomly divide the MIVIA into a training set and a validation set at a ratio of 4:1 to validate the effectiveness of the proposed method. The standard baseline achieves 1.97 on MAE. Then we add model architecture, pre-training, and data augmentation respectively. The final strong baseline boasts more performance than other models. Finally, the strong baseline makes the estimator achieve 1.71 on MAE and 7.18 on age accuracy and regularity. The result shows that our proposed method can predict the age of faces as well as people can, or even better. Moreover, the strong baseline is also the result of our representation learning stage. The estimator performs well at head classes, but shows poor performance at tail classes. As a result, it also performs poorly on the sigma and the age accuracy and the regularity. Then we add the classification stage into the training procedure. And the final estimator shows the best performance on tail classes, sigma, and the age accuracy and the regularity on the MIVIA. The results on the test set are provided by organizers, and it is worth noting that this submission is trained on the whole MIVIA. Okay, this is the end of my report. Thank you.
Thank you, Zhengao. Thank you for your presentation, and congratulations for the results. Okay, so we have finished with the presentations. So is there someone that wanted to ask questions? Okay.
I have a question.
Yeah, of course.
Nobody has.
Please.
So it's a question for you. I was wondering what the distribution of the ages for the hidden test is. Is it similar? Is it something?
Yeah,
it's the training or is it...
Yeah, it's quite similar, but not so different. But not so similar. So it's not exactly the same, but more or less respected. So,
okay.
Okay, so it's not so different. But I think, in my opinion, that the three methods that you have presented, you and the other two groups, have achieved very impressive, in my opinion, performance, because you have taken into account very good the accuracy and regularity inside the loss function, because you have applied your team and the second team applied very similar approaches in terms of loss functions, while the last team which presented adopted a little bit different approach, but designed for long-tailed distributions, so very tailored for this problem. Okay.
Yeah, the other question I have is there going to be a public benchmark for this data set in the future?
It's something that we are thinking about in our research group, because we have to verify well if we can publish these images. Okay, so it's something that we will let you know.
Okay.
Otherwise, in any case, as I did for after the contest, after the submissions, I will be always available for making tests, additional tests on the test set, on the private test set, if we remain private.
Sounds good. Thank you.
You're welcome. Other questions?
Hi. Yeah, hi, Professor Greco. Yeah, that was a great contest you organized. How long did it take you to put this data set together? Because I know you have several publications in this, and it's not an easy job to put together such a large collection. So do you have other goals for this data set in broader goals? How long did it take you, and what are your broader goals?
The goals for the test set, you mean?
For this face recognition, age estimation specifically.
Age estimation. No, consider that the images are taken from the VGG phase 2 dataset, and the images are not mine, of course.
Sure. But still, to curate it is very, it's like kind of manual.
I cannot hear you. I don't know if
hard.
I lost your voice. Sorry.
Oh yeah, I was just saying that manual curation is complex and takes time.
Of course, consider that the VGG phase 2 dataset comes with identities and gender, and in our works of our research groups, we provided and made publicly available both the age estimation labels and ethnicity recognition labels. So it's something that we are using for our paper. So this dataset we are using it for research, but we also made available the labels, so it's available for for all the community.
Right. Thank you.
You're welcome, and thank you for the congratulations. It's a pleasure to make something useful for the community.
Yeah, it's great. Thank you.
You're welcome. Okay, are there other questions? Okay, because I have some questions, just curiosities about the methods. For example, for Nicola, I wanted to ask if you applied the classifier also on the already cropped faces available on the dataset, in the dataset.
Could you repeat the question, please?
Yes, I think that with the detector, you lost part of the face, and the faces were already cropped. Did you also try to apply the age classifier, the age regressor on the wall face instead than on the cropped faces?
And so yes, at the beginning we have the train the classifier on the wall image. Yes, but after we have integrated the age estimation, model with the YOLO, and so we have focused only on the crop faces from the YOLO. Yes.
Okay. Thank you very much. And then for Imad, I had another question, another curiosity. If you have tried to use data augmentation, stronger data augmentation, or batch balancing for further regularizing the performance.
Yeah, so the things we experimented with in terms of augmentation is, so we've started slightly kind of working on the GAN similar to one of the participants, just trying to augment the data using a conditional GAN with the age as input. We did not have enough time to make that work, but we tried to experiment with that, and I think it's something that we can do in the future as well.
Okay. I completely agree that the time is a lot. It's not a lot for the experiments. Yes.
Continue, please. Because we started a little bit late.
Okay.
And yeah, so the other thing we did with H, like to battle the regularity, is just the loss function. We experimented with another paper that I showed in the presentation called label distribution smoothing or deep imbalance regression. Unfortunately, it did not work for our data set. Maybe it's sensitive to the kind of distribution or something like that. But yeah, did that answer your question?
Okay. Yes, it was very clear. If you have, I don't know, if you are planning to with our other papers in this field, maybe you can think about the special issue that I presented before. Thank you, Imad, and thank you to all the group.
Thank you.
All the team. Another question for Yu Hong was in the title of your paper. You mentioned the augmentation. Do you think that it is the key point of success of your algorithm? Sorry, you don't have the microphone enabled.
Oh, okay.
Yeah.
I think it might be our reason to get a second place because of the augmentation. Yeah, it's not an easy work for those images to make because the GAN model is making this small time. Yeah, not much time for us to make much experience in the GAN model. So we take our group member take a lot of time to pick the images that we think it might be useful for the this edge estimator work. Yeah.
Okay, because in my opinion, I think that your data augmentation was very good, but also your choice of the loss function. I think that your choice is in the loss function. Okay, it's just an hypothesis, of course. I don't have the proof, but it's something. I think that both the contributions are important for the results. Thank you, Yu Hong, and thank you and congratulations to all your team.
Thank you for the interesting contest.
Thank you. And just a final question for the group for Zhengao. You achieved a great results in terms of accuracy and regularity without augmentation. Did you try also with augmentation, or you plan to try also with augmentation for further regularization?
Sorry, I didn't understand your question.
Okay, I repeat. You achieved a great result in terms of accuracy and regularity, and without using a strong data augmentation for balancing the data. Do you plan, did you try something with augmentation? Do you plan to do something with augmentation in the future?
We use random augmentation for data augmentation.
Yeah, but without producing new samples. Not strong augmentation for producing new samples in the age groups that are less represented.
Yeah, yes.
Okay. So this was my question. Okay, so you did not try it. Okay. Okay, thank you, Zhengao, and congratulations to all your team. I hope that I will see you in the closing remarks.
Thank you.
It's worth it. Okay, Prof. Patikis, I think that we finished the time.
Thanks a lot, Antonio. Thanks a lot to all the presenters for
I don't hear a voice. It's my problem.
No,
I also don't.
It is Patikis' problem.
Okay. Can I help you some way? I don't know.
I believe it is time to move on to the next session.
Okay. Okay.
So if Rahma is here.
Yes, I'm here.
You can take over and chair the next session.
Thank you. See you later for the closing remarks.